Nick Kollerstrom is an independent researcher and writer. He's an historian of science, a former honorary research fellow of University College London, UCL, and he's a fellow of the Royal Astronomical Society. I give you Nick.
A wonderful new film by the pioneer of what's coming to be called the electric universe theory, American Australians, and we just had a couple of conferences in England about this. I'm a science historian, and so I'd like to try and share with you why this exciting new perspective is important for us. I think modern astronomy has totally lost touch with ordinary people. For a long time it's had nothing to say to ordinary folk of any interest. And the electric universe, it tries to combine ancient mythology, the drama, the memory of the human race, of terrific traumas that had gone on perhaps 5,000 years ago, some kind of traumas that have been forgotten, and what was the sky somehow different then? And that combines with the understanding of what's called plasma. So the whole thing is based on electrical plasma. It's a fairly cool example of plasma. What is plasma? Well, think of the different states of matter. You've got solid matter that we're standing on now, water and air. And these are all atomic, or from atoms. Then there's a further state above the atmosphere, which is called plasma. And that is when the atoms and things are moving so fast, high temperatures, that they lose their atomic structure. And you think, well, that sounds rather rarefied. Well, almost all the universe is plasma. 99.99% of the universe, astronomers believe, is in this non-atomic form. And what the electric universe people are saying is there are huge electric currents flowing through the arm of the galaxy, and stars seem to be strung out in a way that these electric currents are perhaps lighting them up. And this seems to be a new angle on explaining things, and it's a force much stronger than gravity. I'd like you to picture, imagine you've got a little metal sphere on the table. It's being pulled by the whole force of the Earth, that's gravity, but if you just have a little magnet, you can lift it up. So the magnetic force is millions of times stronger than the force of gravity. So what is it that might be explained? Well, in this brief talk, I want to focus on the core idea of what makes the sun shine, the heartbeat of the sun, the pulse of the sun. The sun has got a heartbeat to it of 22 years, and it goes through a majestic cycle that is electrical and magnetic. This is actually a picture of the centre of the galaxy, and what we mainly see here are electrical filaments and current streams all over the place. So a modern view, using different X-ray or ultraviolet, we don't just see stars as objects in space. We see things much more connected up with filaments. This little plasma ball here gives us a kind of model of the way things happen on a far larger scale. We get threads of plasma, what are called Birkeland currents, moving through the universe. The big question arises, are these somehow what powers stars? Are these what lights up stars? Let's have a look at the sun. We start off photos showing it's got a huge corona. Now, corona is a glowing outside of the sun, which is far hotter than anything else in the sun. Now, for half a century, physicists have been telling us, oh, the sun is a nuclear fusion reaction, like a hydrogen bomb. Hydrogen, helium, lithium, these fusion reactors going on at the core of the sun, and that is what lights up the sun. That has been the theory, that all the stars are nuclear fusion reactors. Well, for half a century, people have been trying to reproduce this here on Earth, fusion, and nobody can do it. Nobody can ever make a fusion power on Earth that works. The only thing we can say about fusion is that it goes bang. And that's because a fusion reaction, the energy increases as the fourth power of the temperature, and that means basically it will go bang pretty quickly once you get it, the conditions hot enough pressure for fusion to take place. So there doesn't seem to be, anyone can show, a stable fusion process as is imagined to go on inside the sun. Let's start off by considering the temperature gradient of the sun, you've got this very, very hot thing, about 2 million degrees centigrade, the corona around the outside of the sun. It's a very brightly glowing outside. Within that, you've got the surface of the sun, called the photosphere, which is about 6,000 degrees, and that is really what you see when you're glowing, the yellow glow of the sun, the photosphere. And then you've got a sunspot. A sunspot has got a dark centre to it. And why has it got a dark centre to it? It's got a dark centre to it because it's cool. Now that is the lowest we see of the sun, and it's relatively cool. It's up to about 3,000, 4,000 degrees centigrade. So you've got a very marked temperature gradient. From the inside of a sunspot, surface of the sun 6,000, corona is millions of degrees. Now that is not what you'd expect at all if heat were coming from the centre. The electric universe theory has all the heat and the action on the outside of the sun. That's an electrical magnetic process. That is what you see, it's where the high temperature is, and it's just a kind of conjecture that there is fusion going out the centre, and there's a problem that the temperature gradient is the wrong way. That's the most simple, obvious objection to the fusion model. Okay, it doesn't look as if you've got heat coming out from the centre of the sun. This shows the magnetic field of the sun, which was discovered by satellites. It's got large north-south magnetic fields, and amazingly enough, this reverses every 11 years. Now, notice how you've never heard any astronomer telling you this, have you? Why don't astronomers talk about the staggering fact that our sun has got something totally unknown on Earth, a self-reversing magnetic field? Why don't they ever talk about it? Because they know deep down that it's totally incompatible with their theory, isn't it? If you've got millions of degrees centigrade fusion reactions burning in the centre of the sun, well, you all remember from your science lessons that heat destroys magnetism. It doesn't make a lot of sense having a big magnetic field north-south going through the sun if you've got a fusion, if you've got enormous heat at the centre. If you did have a fusion reaction going on in the centre of the sun, you wouldn't expect it to have a magnetic field at all, would you? You wouldn't expect a north-south magnetic field at all, would you? That is not at all predicted from a fusion model. Just as if you had a fusion model of the sun, you wouldn't expect a corona at all. The huge solar corona, which has very dramatic arcs and discharges, you would expect outside the photosphere of the sun, you wouldn't predict anything much would be happening. So I'm trying to show how everything the sun does is not really expected on the basis of the nuclear fusion reaction. I'd like you all to picture the relation between this north-south magnetic field and the sunspots. I expect you've heard now that we're at a sunspot minimum, okay? Let's have a look at our graph. Okay, here is our sunspot cycle every 11 years, right? Now I'm sure you're all familiar with that, aren't you? That every 11 years the sunspots grow up on the sun and then they fade away. And we're now at a minimum, and scientists are worried that the new cycle should have started and hasn't. And is the sun going to go very quiet? And if so, will that affect us on Earth? The sunspots are a magnetic phenomena. They're huge tubes of magnetic force come out of the sun, then they loop round and go back in again. So this is a magnetic effect, and there's often a symmetry above and below the solar equator. And they travel around the sun because the sun rotates. Okay? And then as you get to a sunspot maximum, they get nearer to the equator of the sun, they get pulled nearer to the equator, and then they'll disappear. Okay? So that's the normal cycle of the sunspots. When the sunspots are minimum, the magnetic field north-south is maximum. So it's out of phase. Then, the next few years, that magnetic field will gradually collapse, and then it will reverse and start growing the other way. So can you see that the total solar cycle is 22 years? Okay? Now can you all picture that? Got a picture? That is the heartbeat of the sun. The heartbeat of the sun. Magnificent, majestic heartbeat at the centre of our solar system. You picture it with a reversal magnetic field, it comes back to where it was every 22 years. And whenever it collapses to zero, the sunspots are maximum. So you've got a wonderful contrast and polarity that no astronomer will ever want to talk about, because they know the theories don't account for it, between, on the one hand, an axial phenomena, north-south magnetic field, and on the other hand, around the equator of the sun, sunspots. And it's a bit like a biological organism, isn't it? But it's a bit like a heart. It's a bit like a heart, really. Your heart goes through 4 stages of a heartbeat. Now, this is a basically magnetic phenomenon, and it's pretty easy to get that electrical theory is going to be more likely to explain this. There's no way, with nuclear fusion going on in the centre of the sun, that you would expect any of this at all, is there? And that is the reason why astronomers don't ever mention it. I mean, I go to a posh astronomical society and they talk about stuff that ordinary people, I can't normally understand what they're saying. It's very rarefied, obscure, they want to talk about distant galaxies. But I think this is much more important. This is the heartbeat of the sun, and it directly affects all life on Earth, the sunspot cycle. For example, a whole lot of people are worried that we might be coming to a minimum. Is there another ice age coming back? 3 or 4 centuries ago, the heartbeat of the sun faded away. I expect you've all heard it. It's called the Maunder minimum. And in the 17th century, you know, the Thames froze over, and cows froze in the fields, and all that stuff, and ink froze in the ink wells. They didn't know why it was. We now say that it's the 22-year cycle of the sun faded out for 3 heartbeats. That's about 66 years. For 3 heartbeats, the sun went silent. Somehow the electric rhythm of the sun faded away. We don't know why, we don't know what it is. There's a consensus today that is linked with the cold weather. There's a theory that sun going quiet will lead to an era of global cooling. And it might seem nice and warm to you now, but the sun going quiet could be linked to an era of global cooling. That is what some Russian scientists are predicting. Okay? Now, I'd like you to picture the close interrelationship between the solar rhythm of the solar cycle, and all life on Earth. As the sun is going quiet, it means the solar wind is getting weaker. Let's just go over what is going on with the solar wind. Every 24 days, the equator of the sun rotates, as we see it from Earth. It's differential rotation, which is totally counterintuitive. I bet you've never heard any astronomer tell you this. It rotates much more slowly at the poles, 30 to 35 days, and much more quickly at the equator, 24 or so days. And the sunspots are 27.3 days on average. Does that number remind you of anything? Well, it's actually the lunar month period, but no, lunar month orbit, but never mind. It's a lunar month orbit, but just a synchrony, you know. Sunspots rotate on average every 27.3 days. So you've got a differential rotation of the sun, which, again, you would not expect at all from the nuclear fusion theory. If heat were diffusing out from the centre, that would dampen and stop any such differential rotation. In fact, the sun is continually throwing out solar wind. Solar plasma is continually coming out from the equator, and it spirals out, rotating. It's an Archimedes spiral. It spirals out, rotating, and all the planets are bathed in that solar wind, right? And if it's losing all that angular momentum, you would expect that to slow down the equator of the sun. That's evident, but you would not at all expect it to be rotating faster than the rest of the sun. Did you get that? The equator of the sun is against everything we'd expect. It's rotating more quickly than the poles of the sun. So there's a mystery here, and I'm suggesting that the current theory of nuclear fusion doesn't give us any explanation at all. What astronomers notice about the solar wind is that the particles, as they come out and they accelerate. They get further away from them, they accelerate, which you'd expect if there's some sort of strong electric or magnetic field. So this again tends to indicate that some electric universe theory is supplying the energy and making it all happen. Okay, let me give you a slightly obscure slide here. We're in this very deep solar minimum now, and the solar wind is getting weaker. Now, what does the solar wind do to planet Earth? We have got a huge magnetosphere around the Earth. The solar wind buffets that, and what it does, it protects us from cosmic radiation. A whole lot of cosmic radiation can't get through to us, and that's why sort of enables life on Earth to exist. We're protected against cosmic radiation. But here is a graph showing how that radiation is getting stronger, and it simply indicates that the solar wind is growing weaker. That's over the last 5 years or so, isn't it? 40, 50, over the last 5 years or so, the solar wind is growing weaker. So the sun is going very quiet, and there's anxiety of what is happening next. Here is a picture of the sun without any sunspots. That's just a solar satellite you see up at the top there in the corner, if you can just see it. So it's very rare to have a sun without any sunspots, as we've got right now. So I've tried to give you a picture of how the energy of the sun is happening at the periphery, not at the centre. According to the electric universe, the centre of the sun is cool. The high energy, what makes the sun shine, is out at the periphery, and it's electrical activity that is going on. It's not thermal energy coming from the centre. It's a high voltage electrical magnetic activity. That is what we see on the surface of the sun. This is very fascinating. Can you see all the filaments leading into the sunspot there? If you see a motion picture of these filaments, it looks as if they're flowing into the sunspot. So it's a very fascinating kind of picture we have here. See all the granules of the solar surface and filaments flowing into the sunspot. Experts believe that there may be nuclear fusion reactions going on in those filaments. Okay, now that's something empirical and observed. The electric universe people are pointing out, and it's not some weird theory. We actually observe spectroscopically elements formed around those filaments and fusion reactions going on. So that looks like a fusion process. Well, there's a lot more that could be said about the electric universe. I just focused on what relevance does it have to our life. Is it any use to us? I think the question of the theory of what makes the sun shine and what kind of sun is it, what does it do, what is the sun doing, how is it relating to life on Earth, I think this is really important. The heartbeat of the sun is 22 years. If you just look at the sunspots, you see 11 years, right? They come and go every 11 years. And if you look at the full process, the magnetic field self-reversing, which is unfathomed and incomprehensible by any scientist here on Earth, no scientist understands or can tell you why the solar magnetic field reverses every 11 years. I'm not criticising scientists for not being able to do this, but I'm saying it's rather shocking the way they don't ever talk about it. Okay? Astronomers don't like to admit that they're mystified. They always want to pretend to you that they've got an explanation. I think it's a great shame that they don't fully acknowledge the wonderful mystery of what is going on in the sun, the heartbeat of the sun, which has so much effect on of life on Earth. If you imagine a futurology department predicting climate and abundance and prosperity and famine, a futurology department, say for Europe for example, would take into account the fundamental cycle of the sun, and also the moon cycle is more to do with the nodes of the moon. I'm not going there, so 18 years and 9 years, and solar cycles 11 and 22 years. And things like, say, the abundance of fish. There's a huge cycles, or just farm produce. There's huge cycles in abundance and famine, and I think if we could be aware of the wonderful cycles of the sun, that would help us and protect us against the constant fear we're given by scientists. They always want to grab your attention by frightening you with something, you know, some dreadful new apocalypse they're trying to imagine. Oh no, it's global warming. Oh, we're all going to boil. Oh no, it's global cooling. Oh, we're all going to freeze. I think if instead we became more aware of the wonderful rhythms and cycles of the living Earth and of how we respond to the sun, I think people would take a lot more interest in astronomy and have more respect for astronomers. Here's just a false colour picture of showing the terrific streams of plasma come around the sun. That the sun is very much connected with the rest of space. There are two different photographs from Earth and a sun satellite, just showing these terrific streams, some sort of filaments of energy connecting up the sun with space. That looks like it. That's fine. Okay, let's continue with this. Brilliant. This is a brand new film, this, on Gaia TV. Absolutely new. You're seeing it here for the first time. Lecture Universe film.
Gravity takes over.
Right, well, thank you, everybody. Thank you. Yeah.